Day 9, page 159, problem 68, AP Physics. Here's your free body diagrams. We set these up in class like this. It's quite involved. Top mass, not so bad. Its weight, vector down. We know already, I'm going back over to the left here, that this is 5 newtons, this F sub G1 that says. So this is also 5 newtons. Those match up. The nice thing about this problem, these are problems you're going to really want to see on the AP test, is right up here at the top where it says constant speed or constant velocity. The net force is 0. There's no acceleration, so it tends to make the problems pretty easy overall once you get the diagrams correct. So for example, in this problem over here, this 5 newtons on the left hand side, F sub N1, is also over here on the right hand side. So this is, I'll use blue. This force over here is also 5 newtons. That's how hard, in a sense, the top mass is pushing down on the bottom mass. It's the reaction force to F sub N1 up on the little guy. So those are a pair. F sub G2, the large mass, is 10 newtons. So I know this is 10 newtons over here. It's kind of, is it going to be a chain reaction? Since that's 10 newtons, F sub N2 must be 15 newtons because it has to balance out the two downward forces. So this has to be 15 newtons. Okay, so let's figure out our frictional forces. We know that the force of friction is mu times the normal force. So let's go with the little guy first, the guy on the left, force of friction number 1. So force of friction number 1, F sub F1, equals mu, given to be, what, 0.4 for all surfaces. So we have 0.4 times F sub N1, which is 5 newtons. So force of friction, doesn't look good there. First force of friction on the top, between the top and the bottom block, is 2 newtons. And similarly, F sub F2 at the very bottom surface is mu 0.4 times the normal force there at the bottom, which is 15 newtons. So that comes out to be force of friction number 2 is 6 newtons. Alright, so let's just kind of all wrap this up. It goes really fast now. Going back over here, bottom left diagram. I know that this right here is 2 newtons. That's the force of friction retarding that mass. The pulley is massless, the rope is massless, the pulley is frictionless, and everything's moving at constant velocity, so T must also be 2 newtons. That's 2 newtons, so this is 2 newtons right here. F sub F1 we already know is 2 newtons. And F sub F2 is 6 newtons. Therefore, the pulling force must equal 6 plus 2 plus 2. That's 10 newtons. Because everything has to be balanced, net force of 0. The hardest part of this one is that getting the correct diagram for especially the lower mass there.